process of tuning is actually very simple. There are only 2 steps. You have to figure out why performance is bad, and then you have to fix it. And unfortunately, there are a great many managers who actually think that. And you probably have had trouble convincing them otherwise. But as you can see, there are a great many more steps. So how do we tell if an access path is good or bad? Well, first we have to know what are the different kinds of access paths. We have to know which ones are good, which ones aren't, but under what circumstances. You know, a certain access path may be good for certain types of queries and not for others. We have to know what the statistics are on the tables and the indexes and the columns. And those are the cardinalities. We have to know the keys of the indexes, and we have to know the filter factors. So, first off, a quick survey. How many of you primarily work with ZOS? And how many of you are primarily LUW? Okay, so there is a mix. How many of you work with both? Okay, good. Is there anyone here who does not know what a filter factor is? Okay, let's go party. Everybody knows. But okay, the word filter means to remove something. You know, air filter removes dust and other particles. What DB2 is filtering are rows. If we have a query, select some columns from the cust table where the last name equals per cell. Well, is that selection criteria or filtering criteria? It could be thought of both ways. We usually think of it as selection criteria. We're selecting the rows whose last name has the value per cell. But you can also look at it the opposite way. We're filtering out the rows that are not per cell. Now, why would we think of it that way? Well, if you have a query with no where clause, that means we're selecting all the rows. So no selection criteria really means no filtering criteria. So the filter factor is the fraction of rows that satisfy a predicate. So the words filter factor and selectivity really mean the same thing. And you know, selectivity is probably a better word, but both are used. So looking at a quick example of what a filter factor is, if there are 1 million rows in the cust table and 100 of them are named per cell, then we're selecting 100 rows out of 1 million, which is 1 out of 10,000, so the filter factor is 0.0001. Both terms are used. The documentation uses both words in different places. Visual Explain uses filter factor. On LUW in the old command editor, it used the word selectivity. On LUW, the text-based Visual Explain uses filter factor. And why do we care about filter factors? We care because DB2 cares. Now, a general guideline in data processing, not just DB2 or any database system, but even in programs, is the more things you filter earlier, the fewer rows you'll have left for later steps. And that's the general guideline that the DBMSs go by and that you should go by as you're writing things. And it's particularly important in understanding the choice of join method and the join order. If you're joining 5 tables, the more things you've filtered out earlier, the fewer rows will have to be processed for the later steps. Some examples. The employee table has 1 million rows. I tend to like my tables to have nice round numbers, so they all have 1 million rows. Salary grade has a cardinality of 20 values, has 20 different values. If we have a predicate, salary grade equals host variable or parameter marker, the filter factor is 1 out of 20, and 50,000 rows will be selected. If higher date column has 10,000 values, higher date equals parameter marker will have a filter factor of 1 out of 10,000, and 100 rows would be selected. If sex has two values, the filter factor is 1/2. If we have two predicates, sex equals M, salary grade equals 23, the filter factor of the combined predicates is 1/2 times 1/20th, or 0.025, and there'll be 25,000 rows selected, which makes sense. If 50,000 rows have a salary grade of 23, and half of them are male, that leaves 25,000 rows. Now, at each step of the way, it's the number of rows selected and passed on to the next step, or the cardinality, which affects the cost of the access path. But it's the filter factor which determines the cardinality. And that's why we need to understand them well. If you have an and between two predicates, if those two predicates are independent, then you multiply the filter factors. If they're dependent, such as city and state, then if DB2 knows they're dependent, it doesn't do a straight multiplication. And DB2 will know that they're dependent if they're the leading columns of an index, or if we've collected column group statistics on those two columns. On LUW, the index stats in syscat.indexes, we have columns for the first key cardinality, the first two key card, 3 card, 4 card, and the full key cardinality. On ZOS in sysIBM.indexes, we only have first key card F and full key card F, but all the intermediate combinations are also collected by RUNSTATS, and they're stored in syscol.dist.
Question?
Sure.
Did it change in version 12? Because I saw the full key card F also in syscol.dist.
You see what?
The full key card F also in syscol.dist.
Well, full key card F is first key card F and full key card F.
No, the combinations of all the columns, I also see the full key card F in syscol.dist.
Oh, it could be. I didn't look, so I'm not sure. A between predicate is equivalent to a greater than and equal, greater than or equal, and a less than or equal predicate. But DB2 does not treat them as independent because it knows it's not a greater than host variable, it's everything above that. But if you have a less than on the same column, the range has now shrunk of what's remaining. There are two kinds of OR predicates, inclusive ORs and exclusive ORs. An inclusive OR is if either one is true, the predicate is true. An exclusive OR is if it's one or the other, but not both. Well, if we have salary grade is 23 or it's equal to 17, that's an exclusive OR because it can't be both. So in that case, DB2 adds the filter factors. If each one had a filter factor of 1 out of 20, then the combined one will be 1 out of 10. If the predicates are an inclusive OR, then the filter factor will be less than the sum. And basically, it's the sum of the two minus the ones that are both. There are two kinds of statistics. There's what DB2 knows, and that's what's been populated by running RUNSTATS. If you haven't run RUNSTATS, DB2 doesn't know what the statistics are. The other kind is what's actually there in the table. And the two could be different because RUNSTATS may not have been run recently, or you may not have gathered statistics on everything possible, like distribution statistics. And of course, if you're using host variables in the query, then DB2 can't even use the distribution stats. You need to know both kinds. You need to know the first kind to understand why DB2 picked the access path that it did. You need to understand the actual statistics in order to understand the actual performance and why it may not match DB2's estimate. And the same with the filter factors. They're the estimates that DB2 makes based on its formulas and the statistics in the catalog. And then they're the real ones based on the actual data. So the example I gave before, was that estimated statistics or real statistics? Well, they're real statistics because I told you how many rows there were. But I made up that example, so those are actually imaginary statistics. So the actual statistics, to find them out, you have to run queries, counts and group bys and so on. The catalog statistics, you can look in the catalog, and those are some of the ZOS catalog tables. The manuals describe the rules and formulas for the filter factors. And you can take those formulas and calculate the filter factor. And that's what you had to do years ago, but now you can just run Visual Explain. And the big advantage of Visual Explain is not the pretty picture, it's that it gathers all the information for you about all the columns and indexes, what the cardinalities are, and what the filter factors. So it's very easy to look it up when you do the explain. If you wanted to calculate filter factors, such as the real ones, an equal predicate is easy. If there are n values and you're using a host variable, the filter factor is 1 over n. If you have a range predicate, then it gets more complicated and harder to be exact. First off, it depends on whether you've gathered column statistics, whether you've gathered distribution statistics, whether you're using a literal or a variable. And range predicates with a host variable are the biggest problem for the DB2 optimizer, because it has no way of knowing if you're asking for a tiny range or a great big range. If you've not gathered even column cardinality, the default for less than or greater than is 1/3, and a between is 1/10. If you have column cardinality, then the filter factor actually depends on what that column cardinality is. If you're between 100,000 values and 1 million, the filter factor is 1 out of 1,000. If it's over 1 million and less than whatever the next one is, it's 3 out of 10,000. The assumption made on the part of DB2 is that the more different values you have, the smaller the range you're asking for. And that may work well for some columns, but for others it's a terrible assumption. In particular, timestamps. Timestamps have very high cardinality. If you have 1 million rows in your table, you probably have 1 million different timestamp values. But when you have a predicate on timestamps, you're probably asking for a day's worth, a week's worth, a month's worth, which is a very high percent of the rows. So that's one of the places where the optimizer runs into trouble. Now, an example to show how it affects the choice of index. My cust table has 2 indexes. I have a cust number index, and I have an index on last name, and it's the last name index which is clustered, which most of you probably know means that the rows in the table are stored as much as possible in the same order as that index. If I have 2 predicates with between, with host variables, then first off, if I have 1 million rows and each row is 100 bytes, I'm going to fit 40 rows on a 4K page, and there are 25,000 pages in that table. The column cardinality for the 2 columns is between 100,000 and 1 million, so the filter factor for those 2 predicates will be the same. It's going to be 1 out of 1,000, which means I'm going to get back 1,000 rows. If DB2 uses the index on last name, those 1,000 rows are going to fit on approximately 25 pages, 40 rows per page. And DB2 will have to do logical reads or get pages on those 25 rows, and at most 25 IOs if they're not in the buffer pool. If it uses the custom number index, those 1,000 rows might be spread over 1,000 different pages. And so DB2 will have to do anywhere up to 1,000 get pages or logical reads. And the number of IOs could be that high if it's not in the buffer pool, but it may be less. In that case, DB2 is very likely to pick the index on last name. If I change the query so that custom number is between 100 and 119, now there are only 20 rows that will satisfy the first predicate. So even if DB2 has to do random access to those 20 pages, at most it's going to be 20 get pages, and at most 20 IOs. And therefore, in this case, DB2 will probably use the custom number index. You know, a few random IOs are no big deal. So we're going to look at a few, yes?
What would happen if you use statement concentrator?
We'll talk about the statement concentrator later. We'll look at a few explains. We're going to join the employee table and the department table on the department. And I'm sure you've all used visual explain of one form or another. So you know it's generally processed left to right, bottom to top. And I use the word generally, there are some exceptions. And each node has the cardinality of that node, how many rows are being passed up, what kind of operation, such as a table scan, a fetch, a nested loop join, the estimated cost. And we can see here in the join, the one on the left for the nested loop join is the outer table, that's the employee table, and there are 42 rows in the table. The department table has 14 rows. By the way, this output is from DB2EXFMT on LUW. With each node has a number so that you can then page through that output. It's text-based. And so node number 2 is the nested loop join, and it has information about the join itself and the join predicates. So as you can see, we're joining work department equals department number. And there's a filter factor for that join predicate. And there were 14 rows in the department table, so matching up with one of them would be 114 for a 0.07 as the filter factor. The index scan node shows, in this case it's LUW, the start and stop key predicates. That's the same as on ZOS Matchcols. Each matching column in the index access will be a start key and stop key predicate. And again, we can see the filter factor for using that index on department had a filter factor of 1/7. In this query, we have an indexable predicate on employee number and a couple of non-indexable predicates. They're not in the index, hire date and education level. And the indexable predicate will be associated with the index scan node, and the other predicates with the fetch node when it fetches the row from the table. So the employee was a between, and we can see it's been broken up into a greater than 10 and greater than or equal to 10, less than or equal to 20. And each of those two has a filter factor associated with it. Ed level was predicate used the host variable, so we use the default filter factor. There are 8 values, the cardinality of ed level, so the filter factor is 0.125. Hire date was a between with a literal, and so we can see the greater than and the less than with those literals and the associated filter factors. If you use Data Studio's Visual Explain, or one in Data Server Manager, you get the pretty picture with nice color graphics. If you hover the mouse over one of the nodes, it'll show you the cardinality and the estimated cost. If you click on a node, you get all that other information, such as on the index scan, what the estimated cost is, the number of rows expected to be output from it. If you work your way down, you see the predicates. So it's the same information, but in a graphical UI format. Now, we've long been told that Matchcols, the more is better. So is that always the case? I mean, we've been told that, so who thinks that more Matchcols is always better than fewer? Hey, nobody. Good. And as an example, we have index 1 is on column A, B, and C. Index 2 is on column D. And the query has an equal predicate on all 4 columns. Index 1 will give you 3 Matchcols. Index 2 will give you 1 Matchcol. Which one's better? Who thinks it's index 1?
Depends on the filter factor.
Who thinks it's on 2? And who thinks the answer is C? It depends. Okay. And that's correct. And what does it depend on? We already got the answer from the audience. It depends on the filter factors. If index 1 were on country, state, and city, and the predicates were countries US, cities New York, 7 million rows would qualify. If index 2 won the social security number in the US, and the predicate was equal to one particular value, 1 row would qualify. So clearly index 2 is much better in this case. So within a single index, more Matchcols is better than fewer. But if you've got different indexes, it's the one that has better filtering. Joins are affected the same way. It affects which index to use, which join method, and which table should be the inner and outer table. And again, DB2 likes to filter more earlier. So whichever table it's processing first, in general, it wants it to either be a smaller table, but not actually a smaller table, a table that when you apply the predicates on that table will return fewer rows. In general, nested loop joins are good for online transactions, and merge and hash joins, in LUW, are good for batch. And the different characteristic is that online generally accesses a few rows, and batch processing often accesses a large percentage of the table. So a merge or a hash join will make one pass of each table using prefetch, and that's good because you're planning on processing most of the table. The nested loop join, if both tables are clustered on the same key, and it's the one you're joining on, then DB2 will make one pass of each table using prefetch, and it'll be good. But if they're clustered differently, it's going to end up with a lot of random synchronous I/O, and you may even read the same page multiple times. For an online transaction, it may be doing those random I/Os, but again, a few random I/Os are fine. But if you did a hash join or a merge scan, you're going to be processing full passes of each table. So why do we sometimes get the wrong join method? And it's generally because if DB2 doesn't have good estimates, and then the optimizer doesn't know. If the outer table has very few rows being selected, the optimizer has a good chance of picking nested loop. But if we have, let's say we have a predicate status equals host variable, and we've created an index on status because we want to pick up the open orders. There are only 100 a day. We wanted to use the index. But I used the host variable. So the optimizer thinks that out of 100 million rows with 5 status values, 20 million are going to be returned on average. So it's saying, okay, I'm going to do a merge scan join. And so instead of taking milliseconds, that online query is now taking 10 minutes. On the other hand, if we had a batch query, and if DB2 thought that only a few rows were being returned, it might pick the nested loop join, and now instead of 10 minutes that it would have gotten from the merge scan, it may take 2 hours, because it's going to do all that random I/O. And an example where that might happen is you have an index on the amount field in some table. The amount field has very high cardinality. If you say amount equals question mark, DB2 will think there's only a handful of rows going to be returned. But your query has a whole bunch of predicates, including amount, but for this query, you've passed in amount equals 0. And it turns out there are 100,000 rows with amount 0. You know, it's an uneven distribution, but you used a host variable. So how do we give DB2 more and better information? The first thing is to make sure your statistics are up to date. The second thing is to gather more statistics, which we'll get into. RI can give DB2 more information. The choice of literals versus host variables. There's the re-opt option. On LUW, there are statistical views. We can manually update the statistics if we don't want to run a full RUNSTATS and we think we know better. And finally, we can use selectivity hints. So variables are good to use because one statement can be used with different values. So that's good from a programming point of view. And for dynamic SQL, you get better statement reuse from the package cache or the dynamic statement cache, and the full prepare doesn't have to be repeated each time for the exact same statement. But literals can be good because then DB2 can take advantage of the distribution statistics. And in some cases, it can lead to a much better access path customized for that particular literal value. Range predicates can also benefit from literals. If we have the high 2 key is 100 and the low 2 key is 1, then you're going to get a very different filter factor for column A greater than 98 than column A greater than 2. Does it always matter? Not always. If you don't have column statistics at all, DB2 is going to use default filter factors, so it doesn't matter whether you use a literal or a variable. If you don't have distribution stats, DB2 will assume a uniform distribution. Distribution stats are the n most frequently occurring values for a column. And you can configure how many to collect with your RUNSTATS. On LUW, there's a default as a config parameter. But on the RUNSTATS command, you can specify a different value. On ZOS, there's a global default, but again, you can specify a different value on the RUNSTATS. On LUW, it's very common to collect distribution stats on all columns. And it's what IBM recommends, and that's what the majority of shops do. On ZOS, it's less common. And in the old days, when the CPUs were slower, a lot of shops didn't even collect column cardinality. So is there anyone here who does not collect distribution stats on all columns? Okay, so nowadays most people do, but there are a few who don't. And are you ZOS or LUW? Right. And you don't actually have to collect them on all columns because if a column has uniformly distributed data, you don't need distribution stats. You don't need distribution stats for your customer ID.
So when I run RUNSTATS index all key card, is this a distribution statistics, or is it not?
It will give you distribution stats on those in the leading index columns.
So I think everybody collects distribution statistics because it's the default.
Only on the index columns.
Yeah, on your index column.
Right. But you also have columns that for which you never have a predicate. I mean, at least not in production, where last update user ID equals a value. It's not a predicate you typically have within your application. So you don't need distribution stats for it. But column cardinality is you can't do without. And it is recommended, collect distribution stats on everything if you can. If you have time to run the job, it's good to have. I then have a more detailed example, which are in the notes pages, but we're not going to have time to go through that. Now, there are times we have programs that were written with literals or with parameter markers, and we wish they were done the other way around. And if we can't change those programs because it's a vendor package or the developers don't have time, they don't want to be bothered, we do have a couple of optional mechanisms where DB2 can change from one to the other. There's the statement concentrator, also called literal replacement, and there's the reopt bind option. In the statement cache, its main purpose is so that dynamic SQL doesn't have to re-prepare the same statement. But if you have literals for high cardinality columns like customer ID, person ID, if you've used a literal, every one of those statements is different. And DB2 has to do a full prepare for each one that's executed. The statement concentrator, if that's turned on, will take those, first it will look to see if that exact statement is in the cache. If it's not, it will take the literals and turn them into parameter markers. And then look again to see if that version is in the cache. And if it finds it, it doesn't have to do the full prepare. And it can be turned on globally with a database config parameter in LUW. It can be done for an individual program or a connection with a connection or a prepare attribute. And it can be done with a bind parameter in LUW. On ZOS, it can be done with a bind parameter in version 12. A month ago, this slide was not completely accurate for ZOS, but today it is, provided you migrate to version 12, which is a good idea. Now, the plus is that you get statement reuse. The minus is that the literals won't be used for access path selection. So if your query has person ID equals 3 and status equals question mark, and you wanted to use and status equals 5, and you wanted DB2 to use the status index, if both of those literals are turned to parameter markers, you won't get that status index. But there is an escape clause. If you use a mix, if you have some parameter markers and some literals, then DB2 will not concentrate it. Under the assumption that if you've used a mix, you did it on purpose. But again, if you have a vendor package and that's how it comes, you have no choice. You can also go the other way around. You may have parameter markers, but you'd really like DB2 to give you different access paths depending on the value you pass in at runtime. So there is the reopt option, which has several choices. None says do it as normal. Always says every time it's executed, see what value was passed in, and then redo the access path. So the good thing is you get customized access paths, and the bad thing is you've got the overhead of access paths determination each time. So generally, you should write your dynamic SQL with parameter markers or host variables, but where it will make a difference, use literals. And that's for a low cardinality column with highly skewed data. But if you have software package and you have no other choice, then you could consider statement concentration. Now, when I say you have no other choice, check with the vendor, because some packages actually have an option. For example, Cognos can generate the queries with literals for everything or with parameter markers, and it's an option you can turn on or off. So don't assume you can't if it's coming out one way. Check the documentation, check with the vendor, and see if there is an option for doing that. Yes?
The question on rewrote. The documentation says it's mostly for dynamic SQL. Is that correct, or is it also for static SQL? Because that's quite unclear if you read the documentation.
I believe it's for everything, right? Little statement concentration? Or is
The question was...
Is statement concentration only for dynamic SQL or for static SQL also?
The
A reopt.
Reopt works for static as well, but it makes your static behave like dynamic.
Right. So the answer was that reopt works for static and dynamic, but of course your static is now doing the same work that dynamic would.
Yeah, if you set it to...
Okay, so the most important thing is to run RUNSTATs. If you have out-of-date RUNSTATs, run them. Make sure you have column cardinality, collect distribution stats. Histograms are distribution stats for ranges. And column group for columns that are correlated, and for which you have predicates that use both columns. You can do this column statistics, including column groups, on a subset of columns. But there's a big difference between ZOS and LUW. On ZOS, the stats that are collected are additive. It means if I asked for column 1 and column 2 on my first run, and then I asked for statistics on column 3 on the second run, the catalog will now have the statistics on all 3. On LUW, each run of RUNSTATs wipes out the column and the column distribution stats for all prior runs. So make sure that when you run RUNSTATs, you list all the columns you need each time. So why are statistics often out of date? And it's because FF stands for something else other than filter factor. Anybody know? It stands for fear factor. Many shops, many managers are so afraid of an access path change that might be for the worse that once they have a good set of access paths, they never want to run RUNSTATs again. And that really does happen in shops. Hopefully not yours. Well, their answer might be, but a good access path today will be good tomorrow also, right? Well, no, because things change. The number of rows change. The column cardinality changes. We've added new statuses, new payment types. The column distribution changes. We used to sell mostly shoes, now we sell coats a lot. And especially related objects can become out of balance. I'm not running RUNSTATs on everything, but if I make a table definition change, I'll run RUNSTATs on that one table. I create a new index, I'll run RUNSTATs on the index, but not the table. Well, I wouldn't, but people do. And if you don't run it on everything related, they're out of balance. Both tables were 100 million rows 5 years ago. Today, one of them has 800 million rows and the other one only 200 million rows. That's a big difference as to which table should be inner and outer on the joins. Is there anyone here who does not run RUNSTATs on a regular basis? where regular could be weekly or monthly.
We only run stats after reorg. So maybe it's a bad idea to run RUNSTATs regularly and you don't run a reorg because your cluster ratio can go down and then the query get a bad access point.
Okay, so one person only runs RUNSTATs after a reorg. Do you run reorgs regularly?
Yes.
Okay, so
If it's necessary.
right, so the reorgs, well, yes.
We run reorg when needed, so we have the software deciding this also RUNSTATs.
Well, if you run a reorg, it's good to run the RUNSTATs after it.
But not necessarily because you run redefined after that.
Well, okay, I'll get to that in a second. It's good to run the RUNSTATs after a reorg, but if you never run reorg on certain tables because they don't need it, it's still good to run RUNSTATs regularly to get the new statistics. It's good to run RUNSTATs after reorg because you have things like foreign direct references and on LUW they're called overflows, and if you've cleaned them up with the reorg, you want the catalog to reflect that. The next question was, should we rebind after the RUNSTATs? And the answer is you don't have to. If you want to because you want to pick up new access paths, then sure. But otherwise you don't have to, but you know that the statistics are up to date for if you do have to. The exception to that, of course, is when you're migrating to new versions where things have changed and you're likely to get new, better access paths and other reasons for wanting to do rebind.
Joe, going back to when you were talking about filter factors on indexes, you've got index 1 and index 2. If the filter factors are the same and you've got one stat which says one index has got 4 levels and one has got 5, would the optimizer usually choose the one with the least levels?
Well, in general, fewer index the question is, will the number of index levels affect what the optimizer picks? And the answer is yes, in general. Fewer index levels are more efficient if you're doing direct access, random access to a row. If your access path happened to be an index scan, maybe you're processing the whole table, but this table you don't need the data row, you just need the index, and it's doing a full index scan, then the number of index levels doesn't matter, you're only reading the leaf levels. So it depends on the individual situation.
Just a remark. Would it not make more sense to run a RUNSTATs when the statistics are to run one? It depends on statistics, right? To simply run a RUNSTAT while I want to run a RUNSTAT is not a good idea, I think.
Okay, the question is wouldn't it be better to run RUNSTATs when the statistics have changed? And if you have a table for which the statistics don't change, then there is no need to run the RUNSTATs. Many shops don't have enough DBAs to support the number of tables they have, and they don't really know if the statistics have changed. Because unless you run queries with counts, how do you know they've changed? If your shop is well balanced and you understand your data well and you know what's happening, then you may know. But there are a lot of shops that don't really have that good an idea, and in that case, doing the statistics is a better idea. So they're up to date.
Real-time statistics.
What?
You can look at the real-time statistics and then you can see how many inserts, deletes, updates happened since the last week.
On ZOS, yes, you can, but you know, chances are most shops don't look at the real-time statistics for that purpose, you know, enough to determine, you know, you have thousands of tables, you know, do you want to, are you going to we want to try to automate as much as possible, and is it worth manually picking out? Sometimes it is.
You can write a program of X or whatever.
You could write a program to do that for you.
Easy, very easy, small script.
Mm-hmm.
There exists a SQL for that. I mean, on the IDUG website, we'll find a SQL for doing exactly that, selecting.
That's a stored procedure, the ACOX, which allows you to do that.
Right, and the comments were that on the IDUG website there are scripts that will check the real-time stats and let you know what's changed and how much been added and so on. And DSN ACOX to check that.
It's not a magic.
I think version 13 is adding a magic feature.
Okay.
Right, John?
That's a season.
Okay, LUW will do it in 12.5. Okay, so the recommended option on LUW is run stats on the table with distribution, which will gather it for all columns, and sample detailed indexes all. Detailed indexes gives more information than just saying indexes, and sampled says it doesn't have to check everything for the detailed indexes. It's not going to affect the accuracy, the sampling of the detailed indexes, and in fact in 10.5 the sampled word there is actually the default. And so we're going to get cardinality and distribution. Num-freq values will tell how many frequently occurring values to collect, num-quantiles for the histograms. But on LUW, you can only gather distribution stats on individual columns, but not column groups. On ZOS, you can collect them on column groups. On ZOS, just RUNSTATS table space, or you don't even get column cardinality statistics. But if you use the table option without even mentioning which table, then you'll get the cardinality. And the distribution stats, you can do freq val with count of how many you want, histogram with num-quantiles. The indexes are collected with the num-cols option before the freq val histogram. But be careful, if you have a 3-column index and just say num-cols 3, you're only going to get the distribution stats for that 3-column combination. You won't get the distribution stats for the first column alone or the first 2. If you want those, you have to have 3 different num-cols occurrences. Num-cols 1, num-cols 2, and num-cols 3. Joins are tricky. How many rows from the inner table are going to match each row of the outer table? If you have referential integrity, that helps the optimizer. For example, it'll know that each child will match a single parent if you're joining on the foreign key column. Unenforced RI, in which it's also called informational RI, DB2, you're telling DB2 when you make that definition that there is a relationship, but DB2 is not enforcing it. And the optimizer can use that information for its access path determination, but you have to be careful. Since DB2 is not enforcing it, if you haven't maintained and made sure that there really is a matching parent, DB2 might also simplify the query. If you're not using any columns from the inner table, and it's an inner join and DB2 is assuming there's a match, or the parent table, it may simplify the query and eliminate one table. So LUW 10.5 added a new option called not enforced, not trusted, which tells DB2, yes, there's a relationship, but use it for your statistics and filter factor estimations, but don't simplify the query, eliminating any tables. Which is really good, because I wouldn't trust us either.
Question: why are you referring to foreign keys and primary keys? Because if you have a unique key, you are in the same situation. You know, those rows from the parent or from the child table, they will match in the parent table because there's a unique index.
Yeah, if you've made an RI constraint between the child table and the parent.
Yeah, but if you haven't,
it doesn't know you're going to match some index in the parent. But
the joint criteria will tell you that.
No, you're saying find me the rows that match. But it doesn't know that every one in the inner table will match the outer one if there's no RI constraint.
I don't understand that.
We can talk about that more afterwards. Now, in general, though, if you don't have RI, DB2 doesn't really know how many are going to match. And I think that its estimates are too low in general, because it's two arbitrary tables with two arbitrary columns. If I'm joining them, there's probably going to be matches. Otherwise, I wouldn't want to join them. But, I think very often the estimates are too low. A statistical view is another option in LUW where you create a view and collect statistics on that view. And you can capture more complex statistics, such as of joins and subqueries and expressions. DB2 will actually evaluate the predicates in that view and the query and collect statistics on it and store it in the catalog. And then if you submit a query that matches that view in some degree, the optimizer can use that. And you do it by creating a view, altering the view to enable query optimization, and then run stats on the table with distribution on all columns. And starting in version 10, prior to version 10, you have to say run stats on table. Starting with version 10, you could say run stats on view. And there's good examples in that article on developer works. But they can be quirky and difficult to get exact, especially for really complex queries. So finally, we've tried everything. We've collected all kinds of statistics, but sometimes DB2 still doesn't have enough information. Again, range predicates. How big a range are you asking for? I didn't collect column groups on everything that I might have predicates where they might be related, but if someone's created a query that uses them. If I have work tables or global temp tables, how many rows are in it? The optimizer doesn't know. So if everything fails, we can do selectivity overrides and tell DB2 the filter factor. Other choice is to do access path hints, which on LUW are called optimization profiles or guidelines. The difference is that in an access path hint, you're telling DB2 what access path to use. You get exactly what you asked for, whether you're right or whether you're wrong. With a selectivity override, you're giving DB2 more information, but DB2 still picks the access path. And this effect was first described many years ago by Mick Jagger. You can't always get what you want, but sometimes you'll get what you need. So in selectivity, we tell DB2 the filter factor. In LUW, it goes right in the SQL statement, right after the predicate. You have to set a registry variable to enable the use of selectivity hints. And the manual says the choices are yes and no, but all also works and actually enables it in a few more situations than yes. Is that still true, John? Okay. The answer is it's still true. So if I say work department equals host variable, is that 10% of the rows or 90%? If I say the selectivity is 0.4, then I've told DB2 that it's 40% of the rows. May not be, but that's what I've told DB2. There are limitations. There are some predicates it can't be used on. It can't be used on between. You have to break up the predicate into a greater than, equal, and less than or equal, and then put on selectivity on each. Selectivity can be a moving target. As the table grows and the distribution changes, the filter factors change too. And join predicates are trickier to handle because it depends on the cardinality of the inner table, and running out of time, so I won't go into detail on that. On ZOS, there's the access path repository, which is used both for access path hints and now, and starting with version 11, for selectivity overrides. And they can be turned on globally for all statements that match or only for specific packages. And there are three kinds of hints, and the only one we're going to talk about today are the selectivity overrides. So the access path repository has a set of catalog tables, and those are the three for selectivity overrides. One for the query, one for the predicates, and one for the selectivities. You also have the three user tables that you create in which you're going to feed into the access path repository. So you populate your user query table, you do an explain, and that will populate the other two tables with the filter factor that DB2 calculated. Then you can manually update the selectivities of the predicates you want to change, and the whole set is called a selectivity instance. If you want, you can create other instances with a different combination of selectivities and giving each one a weight, and the full set's called a profile. But, that can get very complicated, and DB2 can still only pick one access path. It's probably not worth going into that much detail and effort to make multiple sets with weights. So the process is you issue a bind query, which will populate the IBM tables, do an explain on your query to verify that it's using the access path you wanted, and then of course you have to execute the query and monitor it to see if it really did improve things over the access path you would have gotten. And that link has all the details of how to do it. So I'm going to skip that one because we're getting late, but which do you prefer? The access path repository or the selectivity clause in the program? The advantage of the repository is that it's external to your program. You can modify the values without changing the code and redeploying the code, and it can affect all occurrences or just those in one package. The advantage of putting it in the program is that it's internal to the program, and the developer is aware of its existence. If the access path hint or the selectivity hint is external to the program done by the DBA, good chance the programmer, especially a year from now, doesn't even know it exists. He changes his query, and that override no longer applies. If it's in the program, he'll see it. So it's a much simpler process, but of course, the danger is if it's that easy to do, programmers who don't understand filter factors may change it, inappropriately. Any other questions? Okay, thank you.